Sivencrona, thank you for joining me today.
Yeah,
Hope you're doing well.
I'm fine.
Well, first, let's get right into it. Several forms of advanced driver assistance technology, such as automate lighting and adaptive cruise control, have been around for years. What technologies are you trying? Well, not you personally, but are trying to make their way to the autonomous vehicle of tomorrow? And which features do you believe need more improvement in autonomous vehicles?
Well, I've seen a gradual improvement and development here. Obviously, we started with the camera systems, and that, of course, can detect the high beams. And we see that autonomous grade of applications will improve, will increase with each and every year model, basically, of the cars.
Yeah.
And it means that we had, you said, adaptive cruise control. We have today also city safety. That means that you have full autonomous brake in lower speeds down to zero.
Wow. So is that able to kind of see the danger ahead and sort of adjust its speed and braking patterns?
And these are all, requirements from the Euro NCAP and NHTSA.
Okay.
So it's coming. I mean, adaptive cruise control has been around for like 5 to 10 years, right? And city safety for 5 years, maybe 6. And now with this, you have the traffic jam assist, which means that in lower speeds, you will actually keep track of the lanes, the lane markings, the barriers, and try to keep yourself, the vehicle within the lanes. So we do already see kind of autonomous behavior, not full autonomous drive, of course. So I will think it will become an evolution. And along with that, the concept needs improvement. Sometimes you need to go back and improve the platforms and things like that, but it's an evolution.
Yeah, okay, very good. Could I just ask one quick question? As far as you being able to sort of get involved, what if the vehicle, as far as staying in its lane, may make a mistake? What does the driver do then to sort of get in the middle of that process and get it back on lane, back on where it's supposed to be?
Yeah, I mean, when we first started, with the ISO 26262 standard, it was, braking, steering could fail, and then when it failed, like full steering or full brake, what could the driver do? And of course, some countermeasure was thought of, and the research has been ongoing. I've been in one project with it was torque vectoring. That meant that you can actually get the car to start to skid, and that resembled actually a side wind. So they tried to see how drivers reacted, and it's somehow it's a lot of research going on here how drivers will react. And there is one project in Sweden called Modus, which is a project to try to understand what the driver really sees, how the driver will act, what would really be supportive functionality as well. Because today we think, we are inventing a lot of applications, feature. This we need and that we need. We are inventive. But the driver, when you do research, what is really supportive for the driver, it's not the same thing.
Right. That makes sense.
It's interesting.
Yeah, interesting. So what can people look forward to learning about during your speaker session? Can you just go into your topic at hand and what you especially hope people can kind of take away from you?
Yeah, I mean, first, of course, I just present the status of today's autonomous drive, which are no full autonomous cars are available really on the market more than in like Google's. They have fully equipped, very expensive hardware in it. So there is no production-ready autonomous drive. And this is according to NHTSA, it's like 5 levels of autonomous grade. We are not at the high levels yet. I will touch base on that a little and definitely show the paradigm shift from traditional safety-related applications covered by ISO 262 and autonomous drive, where it's very complicated to apply this standard. And then I go into the challenges of that really, and then verification.
Right.
How can we verify? I mean, it's one thing to have one car running around, driving around, and you put a lot of effort,
Right.
and then you have 10. Well, what will happen? And then you get a penetration into the actual fleet. Is it 5-10%? Well, it will be millions of cars having these functions, and it means that the failure rates need to be kept very low. A likelihood of one car failing is basically very low. But if you have 1 million cars with the same hardware and software, you can imagine what can happen on the highway in LA, where you have 1 million cars driving at the same time, with a penetration of maybe 10-20% of autonomous. So this is interesting, and that's what I touch on here as well. And then I do speak about what is my most interesting topic. It is to establish core concepts. In the past, I developed something called the safety element out of context for this standard.
Oh, really?
Yeah. The goal with that was that it's really hard for the suppliers and tiers to come up with a well-described subsystem that can just, like puzzles, that could fit into the OEM's expectations, because the tiers have a lot of customers, and they don't want to redevelop everything for a new OEM. And that means that how can we come up with the right definition of objects, interfaces, and everything that touches autonomous drive, and also what is a sensor fusion? What should that deliver? What are safety concepts using sensor? Because the standard itself cover errors in software, systematic faults, and random hardware faults, and also systematic, if you may say so, hardware faults. But the ISO 262 is not so precise on that it handles also the function. I mean, if the function doesn't really discern between two situations, because you couldn't think of it, what will happen? So that's something that I will touch with my talk here.
That's very good. That'll be very interesting. I think a lot of people will be very interested to hear about that. My next question for you is, avoiding accidents, driving in inclement weather, and sensing foreign objects are critical. In self-driving cars. What core technologies do you see yourself being implemented into autonomous cars that could improve, upon these things, upon these safety issues?
When you speak about core as in sensor, I mean, so far we do have, of course, vision-based system today.
Vision-based systems.
Yeah, and we have radar that is a supplement to that.
Can you go into vision-based a little bit?
So core from a vision is today, it's a research that went into advanced, and then you somehow have what you have. It's an enormous amount of money that has been spent in this vision technology.
Right.
And then if something is changing now with the needs from autonomous drive, so I mean the problem is to reuse what was good for ADAS, that is ACC and ABS.
Okay.
I mean, how can vision be ensured to also fulfill the autonomous drive? This is where I think the core technology needs to revisit a little and see, did we really invent the right thing when we did for ADAS, so that it is useful for AD, if you understand what I mean. That's where I think a lot of research needs or projects need to be started.
And would you say that is one of the more important technologies that you're going to implement for safety, or do you think that's just a piece of the puzzle?
I mean, it's a piece of the puzzle, of course. I mean, with AD, we have GPS, which needs really to be analyzed. What will happen if you send the wrong GPS data from the cloud, or you have the wrong maps? I mean, there are so many errors, and the fault assumption is not really there, right? So I think core is also to know what we need to define when it comes to
and
faults.
that's something largely in part of what you're going into in your speaker session.
Yes, as well. So I do see that it's tricky, really, to define this, because the cloud services, the GPS and the V2X is something that needs to go through really this thorough product development in
V2X,
order.
that's the vehicle itself is communicating with basically everything around it.
And I think without this efficient and high availability autonomous drive is not possible.
No.
Because if something happens to the car in front of you, okay, sometimes even today's system can detect a car in front of your car, but not with a high likelihood. So you need to see these strings in the traffic,
Communication between one
so you need to
thing
understand a few hundred meters in front of it, and also for the cloud services to have, here is icy road, and for this, I mean, the analysis of the future. What have we missed? Unknown functionality. I mean, the icy road was something. Oh wow! In Nordic countries, it will be ice when it's cold.
Right.
Should you disable all autonomous drive when it's below 5 degrees?
Interesting.
Or below 32,
Right.
like you said, or 37.
Yeah. So I mean, weather will have, obviously in the first stages of really implementing the autonomous car, will have a huge impact if they're even used.
Yes.
You know.
Yeah, because if you don't know that it's an icy road there and you continue,
exactly.
Yeah, should it be that you have to acknowledge to the cars that we don't have any data? That means that you can't have autonomous drive enabled.
Right.
Yeah. So there is a lot of thinking going on. I imagine it's not my table, so I just try to make the platform and the functions safe.
And you're a part of a panel, right?
Yeah.
Do you hope to kind of go into any certain things? Maybe obviously what you've already touched on.
Yeah. In the past, I was working for fly-by-wire, break-a-wire in the 90s. And we focused a lot about reaching consistent information between ECUs or rudders or whatever in the flight. So we needed to understand that the data really was accepted.
Yeah.
And then we could say that now every ECU knows the status.
Right.
We had some kind of membership and like that. But that has been shifted, into now the whole fusion needs to be consistent with all the ECUs that we have in sensors and actuators, which is an enormous and a very complex situation. And my firm belief here for the panel is that without fault injection, it will not be possible to validate these systems. No way.
Fault injection.
Yeah, I mean, you can have some composable testing that your component is tested, it's well integrated, etc. You have some assumptions, but you will never ever be able to validate the whole system. That is, have you really built the right system without fault injection?
And does that take, for lack of a better phrase, throwing it in, seeing if it can swim type of deal?
Yeah, that's a validation, really. Did it really work?
Right.
So in the aerospace and avionics, you have really developed quite some formalism, both when it comes to fault injection and from a software point of view, or even using heavy ions.
Right.
So you need to produce single event upsets, or you have a lot of gates in your silicon today that you need to test. But it's not possible to test like 2 million gates.
Yeah,
Pins, whatever you call it. The pin level validation. So what should you focus on? How should you build your fault containment?
Right. That is a lot of interesting stuff that may go away over my head. But
Mine as well.
Here as well. So just some more lighter stuff as we switch over from the more intensive questions. What are your top 3 to 5 predictions for autonomous vehicles? Industry 2016.
Yeah, I think again we will see low availability systems coming first.
Okay.
We will really learn from that, and then we will increase it by each year model with a little more. We will see, to begin with, quite a lot expensive redundancy. But when we learn how to use implicit redundancy that is in the vehicle system itself, we will see that the BOM cost will decrease.
Okay.
We will use the cannon in the beginning, but it's only a rifle that is needed in the end, right? And that's really what I see, a gradual evolution with the features. And I don't see that it will be very, what you say, you won't have it in high-speed cars, you won't have it in very high traffic congestion, so you will have to see what the frames are, or the constraints, yeah.
All right. So, following up with that, what were the key highlights that you believe were in 2015 for the industry?
So, of course, the first lane keep assist. Well, I mean, we have had lane keep assist, of course, before, because you could detect the lane and you could sort of
so if you knew it was going outside
but that
the
was not really fully safe, because it meant that if you left the lane to the right, you could actually bump into it and then go straight over into the meeting traffic. But today, I mean, number one is really that we now have a vision-based and also the support by radar, some kind of lane keep, that's, I think, is the today's most interesting application that we see in the cars, right?
Very cool, and very important as well. Where do you see the regional versus global development progressing in the future?
I'm always a little puzzled about, I mean, in Europe, especially Sweden, where I come from, is like, if your car breaks down, the insurance companies and the government has kind of made it fairly easy for the OEMs, because there won't be any big lawsuits or litigation or whatever you call it. But when you do this in the United States, people are kind of knowledgeable that the Toyota case, for example, we have had other cases where it meant a lot of money to be paid from the OEM. And this is what I think, if that was a little in the question.
I think so,
I mean, this is interesting to see what the global will be. In Europe, I think it will be fairly easy for the OEMs to have a best effort, because we know that these new products will save life. We definitely know that. We have tested that. But if something goes wrong, I mean, what is best practice? What is state of the art? What is negligence? What is misuse? So this is So this is very interesting. And I don't see. I love India and have been there many times. I don't see autonomous drive as possible as of today. But maybe when you have like 100% penetration, it would rather be the perfect country to do it. Right?
Maybe you're right.
Yeah.
So I mean, stemming off of that, where do you believe the perfect location would be to start, and in, let's say, fully autonomous vehicles, a fleet being
where is less traffic, and I think less populated countries,
anything that's less populated.
And also with good infrastructure. So I think, I mean, like VCC, Volvo, they are having their product Drive Me, where they have a sort of autonomous car driving already today, and in Germany they do have that as well. Every company has their autonomous car, but I think Northern Europe is where you can have less congestion, less hard real-world user profiles, RWAPs. As you know, I mean, if you can keep these fairly well defined, that will make it easier. If you are in India, you will have like 100,000 times harder RWAPs to take care of and design for. So I think a gradual evolution will happen here.
All right. Well, Mr. Sivencrona, thank you for joining me.